Hello friends, subscribers and new viewers of this channel. In this tutorial, we explain how to create minimal Docker images and containers for Python programs on Windows. Let me immediately explain what you will learn in this tutorial. Over here, you can see a simple Python code that I wrote. This code will define two matrices and it will perform several matrix operations on these matrices. My goal is to build a Docker image and a container such that I can run this program by using a single line that will run the container. And I will not go into more details about why Docker is useful and where it's being used. Briefly speaking, it's very useful for robotics applications. Now, the result is shown over here. Here, in this command prompt, I can execute my container, that is, I can run my program by just typing this. And here it is. The code is being executed and two matrices are being printed. Everything that you will learn in this tutorial is just a proof of principle for more advanced Python applications. The main motivation for creating this tutorial comes from the fact that online and in books you will rarely find concise explanation on how to create minimal Docker images and containers for Python applications and programs. Students and people who are not familiar with Docker will often have hard times understanding how to create a simple Docker image of a Python application. This is especially the case for robotics or mechanical engineering students who did not take computer science classes. Students or engineers often do not have time or patience to read 100 pages of manuals or first several chapters of books to learn something that can often be learned or explained in 10 or 15 minutes. Then, we observed that a number of tutorials available online are either incomplete or not written for complete beginners. And the purpose of this tutorial is to fill in this knowledge gap. In this tutorial, you will learn how to create Docker images and containers of simple Python programs and how to run the containerized Python programs on a local computer. The assumption is that you do not know anything about Docker and you want to learn how to start using Docker. Later on, once you learn the basics, you will easily pick up other details about Docker. Okay, let's start with the prerequisites. First of all, you have to install Docker Desktop for Windows. You can download and install Docker Desktop for Windows by going to this website over here and by following these instructions. However, on some machines, especially on older machines, the installation process might be tricky, and consequently we created a separate video tutorial on how to install Docker Desktop on Windows. A link to that tutorial will be provided in the description below this video. The next step, once you install Docker Desktop, is to make sure that Docker Desktop can be run from a terminal. Consequently, click on Start and search for Command Prompt. Now, open Command Prompt and over here, first of all, you can type Docker. And if you see an output, good. Then another good check is Docker version. And if you see this output over here, this means that Docker is properly installed and we can continue with this tutorial. Next, we explain how to create Docker images and containers of a simple Python program. To do that, we first need to create our Workspace folder and a simple Python file. Consequently, you need to open a new terminal or you can use the old terminal. In this terminal, first go to the base C drive, then in the base C drive, create a new folder by executing this command. I will not execute this command since I already have codes on my computer. After that, you need to navigate to the codes folder, and inside of this codes folder, create a new folder called test docker. Then navigate to test docker, and this will be the base or the workspace folder for our project. Our next goal is to create a simple Python program. Consequently, open your favorite Python editor and create a Python file. In my case, I'm going to use Visual Studio Code. To start the Visual Studio Code, I need to type code with a dot. And here it is. Click here, yes, I trust the authors, and let's create a new file. I will click on File, then New File, and I will call my file as test1.py. I will save it in the base folder, and this is very important. That is, you need to save this file in the base workspace folder. And over here, to save time, I will simply paste the content of my file. And over here, I will explain this file line by line. So what's happening over here? First of all, I'm importing the NumPy library, then I'm importing the SciPy library, then I'm printing our first container doing matrix calculus, then I'm defining two arbitrary matrices, matrix 1 and matrix 2. To do that, I'm using numpy.array function, and I'm specifying the matrices row-wise. Then over here, I multiply matrix 1 and matrix 2. Then over here, I invert matrix 2 to obtain matrix 4. And then finally, I compute matrix 5 by multiplying matrix 3 with the matrix 4. And finally, I print matrix 1 and matrix 5. And if this program executes correctly, that is, if the container executes correctly, matrix 1 should be equal to matrix 5. After that, I print end of execution. So let's save this file and let's continue. To create a Docker image and a container out of this file, we need to create another file. The name of that file is Docker file. So let's do that. Click on File, then over here click on New File, and the file should be called Docker file. And save this Docker file inside of our base folder. And you can see that Visual Studio Code is very smart to recognize that this is actually a Docker configuration file. This is a file that will define all the parameters that are necessary to build our image and to run our container. So let's write this file. Over here, to save time, I simply pasted the content of the Docker file. The first step is to set the version or image of Python that we want to use. That is, we need to pull down a tagged Python-based image. And this is how we do it. From Python, then we specify the version and some other version parameters. Here, there are several options. You can simply specify Python 3.12 or 3.10 or any other version, and this will be the base Python. However, if you just type that without any additional parameter or version name, the image might be large. That is, it might be around 1 gigabyte. To reduce the image size, you have several options. The first option is to type this, Python, then version, and then this option or version tag, Alpine. And this will be a smaller Python version, around 100 megabytes, or you can use Slim. This is also a very slim Python image. Okay, this is the first step, and we do it like this. Then we need to set the name of the work directory of the container. Currently, this is not very important, however, you should still specify it. The name is app, And actually, we will never use app in this program. However, let's just specify it. Then we need to copy all the source files from our build or workspace folder into this work directory, such that the build system know how the files are being compiled and where the files. Then after that, we need to install pip requirements. Why do we need to do that? Well, if we go back to our test1.python file, you can see over here that we are importing numpy as np and scipy. And over here, we need to do two things. First of all, we need to define or create a new file called requirements.txt that will specify that we need to install numpy and scipy. And then what's happening over here, this file will run Python with an option m pip install, and it's going to install all the packages and modules in the requirements.txt. After that is completed, we are almost done. The final thing what we need to do, we need to call Python executable, and we need to specify the name of the executable file, which in our case is test1.py. This will build the image, and once we run the container, this file will be run. Simple as that. To complete everything, we need to define this file, requirements.txt. To do that, click on File, New File, over here type requirements.txt and save this file in this base folder. And over here, you just need to type numpy and scipy, and that's it. Save this file, go back to the Docker file, save this file, and save this. And before I conclude, I just have to explain these double dots. This double dot means this. The first dot means that we are copying all the files from our source base folder, and the second dot is the destination folder. That is, we are copying the file to this work directory app, and that's it. Simple as that. Let's save everything. Let's close Visual Studio Code, or we don't even need to do that. We just need to go back to the terminal and let's build our Docker image. And now we are ready to build. To build, we simply need to type this. Docker build, with this tag option, the name of our image. The image will be called, in my case, doc app, and over here I'm specifying version 1. And don't forget the dot here. And once I press this, you will see what will happen. Magic will happen. And you can see that something is going on. You can see over here that we are actually downloading and installing by using pip install. And here it is. Now if you go all the way up, you shouldn't see any errors, and this is perfect. Now if you type Docker images, you should see that we have created our first repository. Here is the image ID, and it's being created 13 seconds ago. And you can see the size. The size is around 400 megabytes. This is because we have base Python, we have numpy and scipy. And the final step is to explain how to run this container. That is how to start the container. To start the container, you simply need to write docker run, and you need to specify the name of the image. Docker app, let me just be precise, docker or doc app actually. Then you need to specify the version we created, and that's it. This should run our container. And behind the scenes, it's going to run our Python program. And here it is. Oops, I made an error. Here I need to type docker run doc app version 1, which is very important. And here it is. Voila! Our first container doing matrix calculus. We obtained the first matrix, and the result of matrix algebra, they are the same, which means the code is running properly. Before I conclude this video tutorial, I need to explain one additional thing. If you type Docker images once more, you will see that the size is significant. If you have a large number of images, the size of these images on your disk might be large. And consequently, if you're not using a particular image, or if it's just a test image, it's a very good idea to erase it. To erase an image, you need to do the following. You need to type docker image, then rm, then you need to specify this parameter to force the erase, and you need to specify either the image ID or the name. Let's specify the name, doc app version 1, and that's it. You can see that now it's erased, and we can confirm that by typing docker images. And now there are no images. Okay, that's all for today. I hope that you like this video, and thanks for watching.